Good morning and afternoon, everyone. We're just going to wait another minute while we let participants get in. And we'll start in 1 minute.
Under 22 participants.
Okay, so welcome to everyone wherever you are, and welcome to the third day and final day of the virtual AOGS-EGU joint conference series on new dimensions for natural hazards in Asia. Today's part of an AOGS-EGU conference series, and the next one will be in Indonesia in September 2021. The themes that we are doing over these 3 days, with today being the final day, are the same themes that we will be doing in 2021. So the 6 conference themes: Monday, we saw hazard development under a changing climate, human-induced hazards. Tuesday, hazards in the megacity, remote observation. And today we will have the final 2 themes, which I'll introduce in my last slide. Now, for the first 2 days, we were very excited to have 410 different people attending from 37 countries, from a wide range of backgrounds, PhD students, but also professors and scientists have been joining. The presentations are available each day online. You can get to them now. Click on the time and you can watch the recorded session for each day. Just a couple of reminders of housekeeping. Panelists will show their videos and have sound. Attendees, the microphone and videos will be off. The sessions will use various items and the sessions will be recorded. To chat, you can use the chat with other attendees. Please select all panelists and attendees if you want to chat to everyone, but the panelists will not be moderating this. Any questions and answers you have, please put in the Q&A. So today, I'd like to start with the session 5, and I'm going to hand over to Anawat right now, and this will be on multi-hazard relationships, transient effects, and dynamic vulnerability. Anawat, over to you.
Thanks, Bruce. Good morning, good afternoon, good morning, everyone. Sorry, I'll just, okay. So once again, welcome to our session, which is the theme number 5 of today. The first session of today, which is the multi-hazard relationship, transient effects, and dynamic vulnerability. We have 45 minutes for our session, and this session is convened by Margaret, Heidi, and myself, Anawat. Our common discussion topic is, as you can see on the right panel, what are effective approach and methodologies to understand and model multi-hazard relationships and transient effect beyond individual case studies. For today, we have 3 speakers who will be the flashlight talks for us. The first speaker is Dr. Joel Till from British Geological Survey, which the focus on the multi-hazard relationship. Second is Professor Olivia Lopanian-Metris from the University of Bern, and focus on transient effects. The third speaker is Professor Rajib Shore from Keio University, which focus on dynamic vulnerability. Ladies and gentlemen, before we start, once again, we will have discussion after the flashlight talks for 20 minutes. If you have any question or suggest discussion topics, please write in the Q&A. Before I start, let me show one poll. here, hopefully you can see this, where, oops. So I hope you can see, okay. So now we have still coming the poll. So mostly our participants are from, well, roughly 70% from Asia and about 30% from Europe. But of course, we still have other participants from other continents. All right. Ladies and gentlemen, let's start the session, and I will hand the time for our speakers. I think I stopped the poll. Okay, so the first speaker is Dr. Joel Gill from British Geological Survey. The time is yours.
Thank you very much. Hello, everybody. It's a great pleasure to be with you. We could go forward one slide, please. It's a great pleasure to be with you and have the opportunity to reflect on effective approaches and methodologies for multi-hazard relationships. This work draws on a number of projects that I've been involved in, particularly collaborating with Bruce Malamud, but also more recently at the British Geological Survey with Roxana Curian and a number of others, and you can see those there. So moving forward again, multi-hazard relationships can take a number of different forms. I'll just wait for the slide to progress. Brilliant, thank you. Multi-hazard relationships can take a number of different forms. So for example, we can have triggering relationships where one hazard causes another hazard to occur. So an earthquake might trigger a tsunami, a tropical storm might trigger landslides or floods. We can have amplification relationships where one hazard may change the likelihood or the magnitude of additional hazards in the future. So here, for example, a drought may increase the likelihood of fires, but not directly trigger them. Or a wildfire may increase the likelihood of debris flows or floods, but again, not directly trigger those, but change the natural environment so that they are more likely. And then the third type of multi-hazard relationship I'd like to note are compound hazard relationships. So where hazards, either independent or related hazards, coincide in space or time with impacts greater than their sum. So it could be a volcanic eruption coinciding with a tropical storm, so two independent hazards that coincide in time and space, or that occur consecutively, but in the same geographical location. And then the tropical storm could trigger lahars, could trigger landslides, could trigger floods, all occurring at the same time and resulting in management authorities, other organizations having to manage the impacts of multiple triggered hazards at the same time. So why do we need to think about multi-hazard relationships? This should be around the kind of the idea of, so if we just, sorry, go back one slide, just at the bottom there, this could be around more holistic land use planning. It could be around trying to integrate compounding and consecutive effects into building codes, identifying efficient and effective risk reduction interventions, avoiding assynergies in risk reduction interventions where the action for one hazard actually increases vulnerability to another hazard, or also helping to bring together different hazard agencies and specialists to strengthen communication across these. Moving on to the next slide. So some general points about what effective approaches are. I think very key to this is that the desired application, so why we are doing this, will inform whether a method is effective. So I think it's important to know what it is that we're trying to do in understanding multi-hazard relationships in order to know what the most appropriate method is to use. I put three words there: comprehensive, systematic, and evidenced. I think it's important that an approach is comprehensive in terms of having a broad understanding of the range of natural hazards relevant to an area, a systematic assessment of the different relationships between those, but also the ability to bring together diverse evidence in order to understand and characterize these particular relationships. I think it's important to recognize that there are interactions between the hazard term of the risk equation and vulnerability and exposure. And therefore we need to look at those relationships in addition to the multi-hazard relationships that I've just expressed. And often approaches need to bring together multiple methods that draw on diverse types of data to characterize relationships. So next, if you just hit the button again, so there are a range of different approaches that we can use, and there's a report by Roxana Kurian, which I put in a reference list here that you can look up, which details a number of these approaches and gives some examples from the literature. I'd particularly like to highlight the work that I've been involved in, which is looking at hazard matrices, both at a global level, but also at a national and subnational level, where we're able to then bring in around 20 different natural hazards and systematically identify the potential relationships between these, drawing on diverse literature, interviews, stakeholder workshops, so moving beyond an individual case study, but uniting lots of case studies to give us a global or national picture of potential interactions, but also broader than pairings, also looking at scenarios or more complex multi-hazard relationships. So if you'd like to know a little bit more about some of these approaches, the final thing just to appear on this slide when the button is clicked are a few references. Particularly, as I say, note the review that Roxana Kurian led on the review of environmental multi-hazards, and the Tilloy paper, the review of quantification methodologies for multi-hazard interrelationships that you might be interested in. But I look forward to discussion later, and thank you very much.
Okay, the next speaker is Professor Olivia from the University of Bern. The time is yours.
Hello, everyone, and welcome. And it's a great pleasure for me to talk to you from an atmospheric and climate science perspective, with a focus on how do we in atmospheric and climate sciences study compound events and how can we move beyond individual case studies. Yes, so I would like to introduce briefly a couple of tools that we have at hand and also mention their limitations, but also their potential. So when we want to move beyond case studies and we're interested in events that occur very rarely, we need a lot of data to look for these rare events. And luckily in atmospheric and climate science, we have such large data sets. We have large ensemble simulations that we can exploit. They are available publicly. They're produced both from the climate community, but also from the forecasting community in the form of seasonal predictions and reforecast data sets. These large ensemble data sets typically have a relatively coarse resolution, in particular for impact models. So they may have information available every 50 or every 100 kilometers in space. If we are interested in higher resolution in space and also in time, a new ensemble data set will become available, the Cordex FPS convection dataset, but these are shorter simulations. So if one is interested in very extreme events, and if one is interested in events outside of Europe, those aren't the good choice. Then there are also so-called attribution experiments that are carried out. these also cover several thousands of years and can be exploited to study compound events. As mentioned previously, these multi-thousand year data sets, they have a relatively coarse spatial resolution. So we need to refer to statistical methods to downscale them to a spatial resolution where we can link the data with impact models. And that requires to use multivariate statistical downscaling so that we can, for example, capture the dependence between wind and precipitation while downscaling the data. Another frequently used approach is to study historical and paleo cases. This also allows to expand the event set to be studied using historical notes and or paleo information on precipitation, on temperature, to study compound events. Then, to actually link the atmospheric conditions to impacts, we either need impact indicators, and those are partially available from operational forecasting centers. They are partly derived from individual case studies, or we can couple the atmospheric information to impact models. Next slide, please. However, this is one point where we still need a lot of additional information. So we need more impact databases, we need more impact models, we need more and relevant impact indicators to then search for the atmospheric and climate conditions that resulted in the impacts. Another point that has arisen from recent discussions is to start considering the link between the spatial extent of events and the connecting societal structures. So, for example, to study drought periods that are droughts that are happening concurrently and how these droughts influence food prices on a global market where trading is happening. So to link the spatial extent of events to the underlying social and economic networks that then spread the impact or contain the impact. And the last point that I would like to mention is that has also found a lot of attention in recent months is the interaction between atmospheric hazards and non-atmospheric hazards. So, for example, for COVID, there have been several papers published on the effects of COVID on evacuations, for example, for wildfire refugees or evacuations in the case of tropical cyclones. This is it from my side. I'm looking forward to the discussion.
Thank you very much, Professor Olivier, for a nice presentation. Our third speaker is Professor Rajiv Shaw from Keio University. The time is yours.
Okay, thank you very much. It's an honor and pleasure to talk to you. And okay, I see start video. Yes. So what I would like to talk about these dynamic changes in vulnerability. I think many of you are possibly aware about this famous diagram, which was put in UNDRR, United Nations Office for Disaster Risk Reduction, Global Assessment Report of 2019, that from where we are and from where we need to be, I think this living with uncertainty is one of the critical factors. And we have also seen that it is not due to the natural hazards and induced vulnerability, but also the biological hazards, which we have been seeing over the last 9+ months. So the vulnerability adaptation or adaptive governance, and innovation. These three things, what we are saying, is possibly going hand in hand. What you are seeing here, the photograph, which is from Chao Phraya River in Thailand, where people are trying to build another floor in front of their, above their existing house to have an adaptation mechanism. But how high is high enough over next 20 years, 30 years down the line? That's a major question. Can I get the next slide, please? I would like to give this example from Bangladesh, in the coastal area of Bangladesh, where I have been personally working for close to almost 15 years, and I have been seeing the dynamic changes in this particular, this whole coastal area. This coastal area was traditionally agriculture based, but for last 10-15 years, it has been changed very strongly to aquaculture. And aquaculture means it gives a good amount of money to the local people, where their economic vulnerability getting a little bit better. But there are other factors, like it brings the saline water inside, and that is creating lots of environmental impact. And also the underground water is contaminated more with the saline water. So what is happening here is the severe scarcity of the drinking water problem, the fresh drinking water. There is water all around, but the fresh and safe drinking water is a major problem. And in this particular area, there are, what you are seeing in the upper part in this small the graph, where this is the rainfall pattern. So usually the major rainfall in this area comes between June, July, August, September. So how to hold that particular rain for rest of the time to have a drinkable water. So there were some local innovation made by local private sector, which is a tank company, and they made a very specific material which actually allows the water percolation and keeping the water quality in a good condition. And then it was actually being promoted by the local NGO, non-government organization, to give some sort of collateral to the bank, and then the local people, they can actually borrow the money from the bank and then can actually return it. And it has also positive impact that excess water can be used for vegetable gardens and so on. So what I'm trying to point out here, that it is not only just try to look at the social issue, but also the technical issue and the information and innovation. There was the app which was developed for this water solution, what we call the water solution, the safe water, smart water solution. And there, all these different types of contamination was mapped, and it was more as a citizen science perspective. And it was very interesting that the penetration of the mobile phone in the Bangladesh, in the rural area, is almost 80 to 85%. And out of that, almost 70% have the smartphone. So with some initially local volunteers, they tried to use this one. And this actually shows the changing vulnerability of the water condition. And that it comes back to the local government. So the local government has some sort of mapping of the different types of contamination. So what is the dynamic nature of this vulnerability beyond the case study? Can I go to the next slide, please? So I think there are two or three things coming up from this particular example. One is that this vulnerability, this addressing vulnerability needs a systemic approach, as we also seen in the first slide in the global assessment report. And we need to possibly address it more as a complex sector, as well as incorporate these dynamic changes. And it is linked to the local governance. So the adaptive governance become very, very important. The innovation brings actually innovation is brought by the local private sector, and in some cases local NGOs. So this multi-sector collaboration becomes very, very important. And this innovation can be social, institutional, technical, and it plays actually a very, very important role. And we often talk about, when you talk about the vulnerability assessment, we often talk about the data issue and the data problem, especially in the field. And we have found that involving citizen or the local group or the local people in the data collection through the citizen science approach, and having an open data policy for sharing this data beyond the governmental boundaries, I think that made also a very, very important thing. So by changing nature of this vulnerability, I think these are possibly a few points which I would like to emphasize, that the vulnerability, the adaptive governance, and the innovation, this will be the 3 keywords from my side. Thank you very much.
Thank you very much, Professor Rajiv Shore. I'm very happy to see the first slide that you share about the typical house in Thailand from my home country. Thank you.
Okay,
Then I
so
will
thanks very
move to
much.
the discussion.
Okay, sorry, Adamat. Yeah, I will take over to moderate the discussion. So I can inform you that we have more than 220 people attending. And so we want to have a lively discussion also with you attendees. You cannot talk with us, but please use the question and answer to state your questions to the panelists. So I would like to ask the panelists, Joel, Olivia, and Rashid, to switch on their video. And before we move forward to the discussion, I also want to mention that today we have a live artist with us, Jenny Leonhardt, and she will draw a picture. We see this enlarged at the moment, about what we are talking about the topics, and tries to put this in a piece of art. So we are very happy about that. So before we go to the questions stated by the audience, I would like to have one quick question in the round of quick answers by the panelists, focusing on our key questions. How could we go beyond individual case studies? So we heard a few approaches already in the flashlight talks, but maybe you could go, quickly have focus on this specific question. Rajib, maybe you want to start?
Thank you very much. I think to me, going beyond the case studies, it is very important to link it into the existing governance mechanism. So how this whole vulnerability assessment can be linked to the regular development framework of the government or the development scheme of the government, that's very, very important. I see one interesting question here that I possibly focused on the slowly changing vulnerability, which is the salinity in the coastal area. But the question is a very important question actually, that how we can also link to a first time scale, which is, say, for example, people travel to work or go to the school. In many cases, in many times we see in the rural area that certain areas of the transport, like the road networks become stopped, or road network actually affecting, we see in many of the cyclone or the typhoon impacts, that if there is a failure in the road network, it also strongly affects the livelihood as well as the education system in different types in the health system. So when you talk about this vulnerability assessment, especially on the dynamic change of the vulnerability assessment, that's where I emphasize about the systemic risk approach, where we need to actually see the connectivity of different types of vulnerability, be it physical, be it social, be it institutional, be it environmental, and so on, and try to see its interlinkages and link that into the governance mechanism.
Okay, thank you very much. Olivia, do you want to comment on this aspect also, about how to go beyond individual case studies? Olivia, you need to unmute.
Okay, sorry. Yes, so in the atmospheric and climate science, to go beyond individual case studies, you need large data sets to look for very rare events and have a sufficiently large sample of these rare events to then investigate. And this is why I mentioned these large ensemble data sets, because there we have thousands of years of data that we can analyze, and where we can specifically look for events that are associated with high impact, and then also basically address the question, how do these change under anthropogenic climate change?
Okay, thank you. Joel, do you want to add a comment from your side as well to this question?
Yes, I'll briefly note that I think individual case studies are an important pieces of jigsaw, and they can, when brought together, I think can give us a richer understanding of the hazard landscape and in any given region. But I think in order to integrate these different case studies to get something that is more than the sum of the parts, there are actually some structural things that we need to look at that I think are important to highlight. So how we work across different disciplines, how we stop working in hazard silos, how we improve communication between the excuse me, the natural and the social sciences, and recognize the different types of data that we're going to need to bring together if we're going to have a more holistic understanding of the hazard landscape. So I think that's the kind of reflection that I would offer.
Okay, thank you very much. So this was one challenge we basically identified to go beyond these case studies. Now we want to ask you, all the participants, about what you think is the major scientific challenge regarding multi-hazards. So I would like to ask all participants to answer this poll. I hope you can see it. And we have prepared some questions about modeling complexity of each individual hazard, or integrating the results of each hazard into a synoptic perspective. Another challenge might be identifying and analyzing interactions between different hazard types. And the last challenge we identified was modeling interactions and cascading effects of different hazards. So I will keep this poll open for a few more seconds, and then I will show the results. So what our audience thinks is the most important challenge scientifically. And then I would like to ask our panelists for a short reflection on this, really short, because we have more questions we want to discuss with you. So I will now end the poll, and I hope you can see the results now. So most of our attendees identified modeling interactions and cascading effects of different hazards to be the most important challenge we as scientists face. So Joel, do you want to have a quick reflection on that?
I think that resonates very much with the Churian report that I highlighted earlier. That report found that there were many examples in the literature of identifying in relationships between one or two hazards, but actually looking at a more complex scenario with multiple hazards and trying to model that was a definite research gap. So I think that highlights a clear research gap in the literature.
Olivia, do you want to quickly reflect on these results of our poll here? Olivia, you need to unmute.
Sorry. Yes, so I'm always adopting the atmospheric and climate science perspective, and it's certainly in our community, modeling the interactions and how they influence the impacts. This is where we are still at the very beginning, or where we are just at the beginning of establishing connections to the various fields that do have the impact models that can then be connected to the atmospheric science data.
Okay, thank you. Rajib, do you want to give a quick reflection on the results?
Yes, actually, currently in the IPCC's current assessment cycle, those who are following it in the first order draft and current, we will be soon coming with the second order draft for working group 2 I'm focusing on. Precisely, this is one of the major gap areas, especially the research gaps. I am in charge with the Asia section, the Asia region. And precisely this is, I think, a very, very important point that we don't have enough this interactive cascading model, especially on interaction of different types of hazards. And then again, from hazards to how we link it to the exposure and the vulnerability. So I think the poll actually is a good representative of the current research gap.
Okay, thank you very much. Now I would like to ask Margaret, do we have an interesting question from the audience?
Yes, we have several interesting questions in this. I just picked one, which in the chat is going to Rajib, but I think it's to all of our panelists. And the question is about vulnerability and exposure are two major triggers of disasters. And the question is, could you please let us know how dynamic changes in vulnerability and exposure could be linked to decision making, and how we can produce data on knowledge to include this? So I think dynamic is a very important part from hazard side, but also for vulnerability and exposure when we consider the multi-hazard. So what is your opinion, and what methods, approaches we can address these dynamic changes? So perhaps Rajib starts, and then the other two panelists contribute as well.
Yeah, I think I would like to just point on this role of the science and technology, especially in addressing these dynamic changes into the decision making. Very unfortunately, I can say from the Asian perspective, when you talk about the science and technology, we have very high-tech science and technology always in our mind. But science is, science can be actually used in a very simplified way with lots of community participation, with lots of different types of current affordable technology what we have in our hand. So I think somewhere in our mind, there are this mental barrier that, oh, if it is science and technology, it has to be very, very high tech. And when you talk to the decision makers in the developing country, they often say that, oh, we don't have access to a good technology. But my stake here would be that how we can make or break rather this type of silos of bringing science and technology to the actual decision-making level in the local governance. And that's what I wanted to show the example on the, when you talk about the adaptive governance and link it to the innovation. And innovation, again, doesn't necessarily mean to be a very robotics level innovation. It can be lots of social innovations which matter. So I would like to emphasize on that part, like the importance of social innovation, importance of bringing science and technology into adaptive decision-making that can possibly link it to these dynamic changes in vulnerability and exposure. Thank you.
Okay, thank you very much. Olivia, do you want to comment on this question as well, please? Olivia?
Yes.
Okay.
So again, from a climate perspective, so this would be relatively long time scales. The changes in vulnerability and exposure are, of course, on the one hand included in the scenarios that are driving the climate model simulations, but can also be included in when the climate model simulations are coupled to impact models. So to change the key crops, for example, that are grown in a specific area. So on the climate timescale, this is all happening using models. So these dynamical vulnerabilities and changes in exposure. I assume on the weather timescale, one yeah, one could work directly with data.
Okay, thank you. Joel, a quick comment from your side?
So how can science and technology contribute to decision making other than producing data and knowledge? I think multi-hazard science is actually a great thing to bring different people together, because you need multiple stakeholders to contribute to that work. And so I think it's an opportunity to act almost as a diplomatic tool to get different groups, different agencies together in the room, and then collectively to foster discussion, improve communication, which I think is essential to good and effective evidence-based decision making.
Okay, thank you. Then I want to start another poll, which is a quite actual one. So we want to focus on the current COVID-19 crisis and how this reduces the coping capacity against multi-hazard events in your region or study area. So I would like to ask the audience again to answer this poll. So there are various possibilities you can answer. So one might be that it reduced the resources for multi-hazard risk prevention. There might be a delayed evacuation, or a reduced capacity of evacuation shelters, reduced capacity for emergency response, or reduced hospital capacities, or reduced resources for financial risk transfer. So these are the possibilities we came up with. So I would still like to ask the audience to answer this poll. I will leave it open for a few more seconds, and then again, maybe ask Olivia to comment on the results of this poll, since she mentioned specifically this combination of this anthropogenic and health crisis, COVID-19, with natural hazard aspects.
May, when you run the poll in this time, perhaps our panelists can also touch the topic on uncertainties. We have several questions on that, how we combine, or if we don't include social science, or for the climate perspective when we have the modeling part, how we deal there with uncertainties. So most of the question I have here is about uncertainties and how we deal this with multi-hazard. Perhaps we can include this a little bit in this answer as well, because we run out of time.
Olivia, can you comment on the COVID-19 crisis, which also brings a lot of uncertainty in our world?
Yes, so the reference that I cited by Carly Phillips was published in late spring this year, and they mentioned potential problems with evacuating people during a COVID crisis. And in the meantime, we have actually observed that this has been problematic in the US in terms of evacuation due to tropical storms, but also evacuations because of the wildfires. And in terms of the wildfires, there was another complication that because of COVID, a lot of prison inmates were released, and prison inmates also contribute to the firefighters in California. So many firefighters are actually prison inmates. So because they had released the inmates, they were low on firefighting staff. So there are certainly direct links between atmospheric hazards and our ability to respond to them and the COVID crisis.
Okay, that was very interesting. Joel, maybe you can quickly say something about you from a practical perspective, deal with these high uncertainties in risk management, not only multi-risk, but all risk assessments.
Okay, yes, I mean, the work that I have done has tended to be more qualitative, semi-quantitative, and I think actually the narrative that goes alongside any figure, any matrix is incredibly important, just to detail those limitations associated with what's included there, the kinds of literature that was included and not included. And I think actually what's really important here is going back to that point of good communication between scientists and decision makers, is making sure that products are not just produced and given and expected to be used, but that there is good ongoing dialogue that helps everybody to understand the limitations of a particular product or model, how it can and can't be used in order to ensure that then is filtered through into decision making.
Okay, thank you very much. So now I hand over to Margaret again to say the final words and say goodbye to you.
Yeah, thank you very much for everyone, for our panelists and all the audience and all the interesting questions. As you see, there are a lot of other questions, and therefore we're really looking forward and hope you will join us next year in the conference. You find the details here on the slide. And yes, we're looking forward for further discussion. I think it's a very hot topic and we got a lot of insights, and please stay connected and go on with this. Thank you very much. And perhaps we can see also the video of Jenny, what she drew during our discussion.
Sure. Hi, guys. So yeah, just trying to summarize kind of some of the key points here that you guys have raised in a visual way. So that's half of the morning kind of done.
Okay, thank you very much. If I could ask all of the panelists from